So we are now basically onto the second part of the course, which is the virtualization, and we will cover it in three different modules. First, server virtualization, then storage virtualization, then network virtualization. Our goal is really to cover network virtualization, but you won't be able to understand that until we cover these two. And so today we are going to first start with server virtualization. And we will talk about as to why virtualize, what are the different concepts, what are the different products, and then we sample of them, and then a format that has been standardized. So the note, storage virtualization and network virtualization will be discussed in subsequent lectures. So this is not the lecture which is complete in that sense. So what is virtualization? Virtualization means that applications can use a resource without any concern for where it resides, what the technical interface is, how it has been implemented, which platform it uses, and how much of it is available. So we are totally unaware of what the physical resources are. Virtual view is all we know what is given to us. So if we want a 100 gigabit disk, we can get 100 gigabit disk, but we don't know whether it consists of 250 gigabit disk or just 110 gigabit disk, or it is 1000 gigabit disk. We don't know what is the real thing is, and we don't know whether it is in Germany or whether it is here, and we don't know whether it is SCSI or whether it is fiber channel, things like that, right? So as long as we don't know the real physical thing and we can use it, that is virtualization. And there are many definitions of virtualization. By the way, I found this one as the best, so I selected this one. Okay. So why do we need to virtualize? Well, we need to virtualize if you want to share something. And if you want to share, that means we have to want to break up into the pieces. Right? So we have a big building and we want to share it. We break into apartments, and that is like a virtual building. It's like a virtual home. So same thing. You have a 10 gigabit link and you really don't need that much. We can share, 3 people can share it, with pieces of 1 2 gigabit, 1 3 gigabit, 1, whatever. Right? Virtualization. Our server, same thing. You might have a server with 18 cores, not really 18, nobody makes 18, 16 cores or 8 cores. And then, you want to share that. So that is one reason, is sharing. Second is isolation. Is that you part of a group where you really want to be protected from other tenants. So, for example, when you dial into your company, or in Vashu in this case, you don't want anybody else to see, so you want isolation. You want to be protected. They don't want anybody else to see your traffic, so that is VPN. That is another reason for virtualization, that you somehow want your own piece. Aggregation, because you don't have big enough piece, you have many small pieces, but you need a big piece, so you want to combine them. So you might take 4 switches and make one big switch, or you might take 4 links, make them one big link, or you might take 4 disks and make one big disk. Dynamics. You need to virtualize because things are moving too fast. Because either you need to have allocation very fast, or you're moving very fast, or balancing because the traffic is coming. For any reason you want to virtualize that. Ease of management. And finally, that is the most important reason, is that virtual things are very easy to manage. Physical things are very difficult to manage. And and somebody has to manage physical things too, but we will find that we just get a virtual view of something and then we manage that, and somebody else who we pay for it manages the real physical thing. And so it makes the deployment, distribution, testing very easy. Advantage of virtualization, first of all, minimizes the hardware cost. So as you will see, basically what happens is, instead of physical servers, so suppose you want to run 10 applications, you want to have web server, you want to have mail server, you want to have that server, this server. Instead of putting them all into 10 physical servers, that's what we used to do before, we put all of them on 10 virtual servers in one machine. The advantage is that now we need one machine instead of 10 machines. So CapEx has gone down. Anybody knows what is CapEx? Capital expenditure. Easily move VMs to other data centers. And for some reason you have to move one VM, you can move it easily. And you can do disaster recovery. If something happens to the main data center, you can go to some other place. And then second thing is what they call follow the sun. You can follow the sun. because in the daytime there is a lot more activity in the United States. In the night time you want to go to China, India, something, because there is daytime over there, night time over here. There is no activity here. Suppose you are at Facebook, there is no activity in the United States, and there is a lot more activity in Asia. So you will follow the sun. You will move your VMs to wherever the sun is. Or you may follow the moon because you want to save energy for some reason. It's not with the users, but your load is such that you only want to go where the electricity is cheap, and generally in the night electricity is cheap, so you follow the moon. So for whatever reason you want to follow, you can move things around. Consolidate idle workloads. And so when you have 10 servers, they might be running 10% of the time, and 90% of the time they're not using the system, so you might as well put them into virtual servers, and then they can use the leftover capacity. Conserve powers, and obviously instead of 10, if you use 1, you save a lot of electricity. Easier automation. We already talked about the management part is easy, so it is lower OPEX, and OPEX is operational expenses. Simplified provisioning, management, all that thing. Scalability and flexibility. And basically you can have as many VMs, not as many, you can really do multiple VMs and then multiple operating systems and so on. So virtualization is given now. Okay? Like you saw in the Google Trends, everybody buys virtualization, everybody knows virtualization, it is everywhere. Today, you really do not do much on the real systems. Believe it or not, when you go to iCloud, that is virtual. When you do Google Docs, that is virtual. So everything we do, a lot of things we do is virtual. Okay? And obviously data center is all virtual nowadays. So virtualization computing, well, it started a long time ago. So before my time, we used to have virtual memory. We still have virtual memory, but virtual memory was a favorite topic at my time. When I did my PhD in 78, everybody was doing PhD in virtual memory. How to virtualize memory. Memory was very expensive, and you wanted to do 10 kilobit, or maybe 10 kilobyte worth of memory with only 5 kilobyte of physical memory. That is the number we used to talk about, kilobytes of memory. And today we have on my computer 8 gigabytes of memory, but still we do virtual memory. Right? So that is the thing. The virtual memory was there, and then we had virtual CDs, virtual disk, and so on and so forth. And now we have virtual memory is not only level 1, we have level 1, level 2, level 3. We have multiple level of caches. So virtualization is there in the memory for a long time. Computing, we started with something called thin client. Thin client was putting a monitor on every desk, and then the real computer was in the back. Well, that was virtual desktop. Then we started virtual servers, and now the cloud, virtual data centers. So people don't want to have a full data center, they would just give it to the Amazon, right, and Google. So if these things are virtual, then networking. Now networking is the plumbing of computing. You cannot do any building without a plumbing. Can you live in a building without plumbing? Not in these days, right? In the old days maybe, but nowadays you cannot. So the idea is, so you cannot do anything without networking. If you want to do virtualization, you need networking there. And so we have had virtual networking for a long time, virtual channels, virtual LANs, and virtual private networks. But there is a lot more which has happened in the last few years. That is what we want to talk about. So let's start with server virtualization. So basically what you do is, you have two operating systems, or maybe one or two. Okay, so you have hardware, on that you run an operating system. On that you run some special program that we call hypervisor, and on that you can run many different machines, each with its own operating system. So how many of you have run virtual PC or virtual machine on your computer, laptop? Almost everybody. So this should be very clear to you that you have your Mac or Windows or Linux host operating system, and on that you run something and you get multiple of some other operating systems, right? This is called hypervisor of type 2. So it requires a host operating system and then the guest operating systems. A better way is to not have the host operating system at all. The hypervisor type 1 does everything that is required, and then the only thing you have is the guest. That is what is done in the data centers. Okay? hypervisor of type 1. And so the guest OS, for example, if you run Windows XP mode, which is kind of a standard on Windows 7, right? You get a XP license along with 7. So you can run that virtual machine. And so that is type 1, type 2. And type 1 runs on bare metals, and the names are Jain, VMware ESXi. So these are popular type 1 hypervisors. Microsoft Virtual PC is type 2. And there are some which can do both, which can run on an operating system and which can run without the operating system. So KVM is an example. All right. However, the story does not stop there. The thing is that to run storage, you need network. To run a server, you need the storage. To run the operating system, you need the server, and so on and so forth. So there is a lot of dependencies. So you run storage on the network, server on the storage, operating system, services, desktops, applications, and users. Users run the applications. Anyway, so this is the hierarchy, and everything can be virtualized. Yeah.
Can you give me an example of
Yeah, so we are going to go one by one. So what is operating system? We already talked about the hardware virtualization. So we basically, the previous slide was talking about how can you virtualize your computer so that you can run another operating system on it, right? Now the question is, can the operating system, what is operating system virtualization? So operating system virtualization basically is a term where you have one operating system which is also the host as well as the guest. It is the host as well as the guest, but you have carved out the boundaries such that people in this cannot affect the people in that container. That is the virtualization part. So you have isolation. All right? And we can call them jails. So people in one jail cannot, affect the people in the other jail. And that is done, for example, when you get a Windows Server 2003 or 8, or multiple people can log in, but they will not be affecting each other. They will not be able to see each other's disk or anything. So Windows Server is an example of operating system level virtualization. And in fact, even on your computer, for example, you can download something called Sandboxy. Or Sandboxy, what it allows you to do is to create a sandbox on your computer, and you can run any program in that sandbox. It will not be able to infect your computer. So if you think that something is infected, might have a virus, you don't take a chance. You just don't run it on your computer. You run it in a sandbox, which is nothing but a container inside your operating system. Understand? So there are many programs that allow you to do that, and iCore allows you to do similar things with iCore virtual accounts. So all that is host equal to guest. That means operating system level virtualization. Desktop virtualization. Desktop virtualization is a desktop with multiple operating systems. So for example, some people here who have laptops with Mac, right, may also have Windows in that same laptop. Right? Parallels, you buy parallels. And you do that, that is desktop virtualization. So you have two desktops, one for the Mac, one for the Windows, running at the same time. So Mac OS X, Windows at the same time, parallel desktop. Hypervisor type 1 is what the parallel desktop is basically. And used for testing software on multiple OS, reduces the hardware cost. Now you don't need two computers to test whether your program works on both Windows and Mac. You can just do it on one. That is desktop. Now desktop also another version called thin client. Now thin client is then when you need lots of computers, but you don't really want to buy that many computers. And this is a common case, whether you have airline reservations or whether you have a hospital or whether you have any system, generally need hundreds of people sitting in a room doing something, and you don't want to give them each their own computer. Then you give them thin client. Thin client is basically a monitor. All right, keyboard and the mouse, along with a little thing which is very simple computer. All the work is done in the server, in the data center. All the files are saved there, but the desktop, generally the screen, is sent here to be displayed. That is called thin client. It has many, many advantages. Not only that saves you money, if somebody goes home or they want to go from this desk to that desk, it doesn't matter. They could log in on any desk. And also it's good in the sense that anyway, we'll see it one by one. So remote server provides most of the computing. All programs or data reside on the remote servers. Yeah, so they don't get lost. So that is what I was getting to, is that if one of these computers fail, nothing happens. Right? Everything is in the data center anyway. And the data center is also probably backed up. So if data center fails, you have a different backup. But here, the data is all safe. Easy maintenance and upgrade. You can upgrade any program, install any time. You can log in on any client. Significant energy savings, obviously, you can see. Examples are Chromebooks. So Chromebooks were designed with this idea in mind. In Chromebooks, all you run is a browser, Chrome, and then everything is done in the background. But there was only one problem with those, was that you needed 3 cables, one Ethernet cable, one power cable, one USB, and all that, right? So now we came up with something called zero client, which is thinner than the thin client. In a zero client, there is only one cable, which is the power cable. You don't need the networking is by Wi-Fi, and then basically USB is also coming by Wi-Fi. So everything is wireless, and you have a monitor, keyboard, and a mouse, everything sitting there, and no cables coming in. You can put as many as you want. Just connect to the power, and you're done. You're ready. All right, thin client. So now we move up one layer up to application virtualization. Now we said applications run on the desktop, right? So application can be virtualized by running it to run on many different operating systems and hardware. So what you do is you write applications such that they are totally independent of the hardware and the software. That is what we call Java. Right? So Java is application virtualization in that sense. Okay? Application code, byte code, runs on many different processors because there is an interpreter which interprets the code for that hardware and that operating system. Java virtual machine. Finally, then we have service virtualization. So what is the difference between service and an application? All right? Service is very similar to the applications, but they are different. Generally, services are things which are done in the background for you, such as firewall, load balancer, proxy servers. These applications cannot run without these, but you don't see them. When you're running a web, when you go to Google, you don't know how many load balancers were on the way, how many proxy servers were on the way, how many firewalls were on the way, right? So those are the services we are talking about. They can all be virtualized. And they're implemented basically in virtual. So we have virtual appliances which are implemented in the software. For example, this load balancer might be in the software, and so it is virtual, as opposed to previously we used to have physical load balancer. So when you go to Google, first thing you need is a load balancer or a proxy server, and that is the address that you get when you go to DNS, and then it sends it to the real servers. Any questions about this, or shall I keep moving? User virtualization, and actually the correct word is user experience virtualization. So user gets the same experience regardless of what they're sitting on. So now, basically, for example, Windows 8, you could have a program running on your desktop or on your phone, it doesn't matter. Same interface, same thing happens. You could be running here and go there. Actually, it's not just Windows 8, but even on many other systems, you could switch between the laptop or maybe tablet, a phone, and laptop. So that is basically user gets the same experience regardless of what the physical hardware is. All right, and so the applications and settings are stored in a central data center. So basically, they are not stored on the device. So that's why you can switch the device. You could be working on the laptop. In a minute, you would go back to your tablet, and you will start from where you were before. Okay, Microsoft has something called UEV, User Experience Virtualization, which allows you to do that, basically. Did I finish everything? Yeah. So that finishes that slide. Now you have a question about anything left? Done? Yeah. So basically we saw that how you can virtualize at any layer, or every layer actually. Next thing is there are some other concepts related to virtualization which are used, and you should know the difference. For example, hardware emulation. I mean, these four concepts which are on this slide: hardware emulation, assisted virtualization, parallel virtual machines, and paravirtualization. I'm going to explain them one by one. So hardware emulation simply means that you want to somehow simulate, or emulate is the right word actually, hardware on the hardware. So you have a x86 processor, but you really want a Spark. Or you have a Spark and you need x86. So you can run some software which does that for you. Yeah.
Well, kind of stupid question is, virtualization, can't be all good, right? I mean, for the hypervisor number one, type one, on top of the host OS, they still have one more piece of software. So that could be some extra cost. I mean, what's the trade-off for the virtualization?
Okay, so I think there is a cost to the hypervisor.
Hypervisor.
Yeah. Let me just tell you, hypervisor cost is nothing compared to the Windows license. I mean, so that gives you some idea. In fact, people don't charge for hypervisor anymore. They charge just for the managing the hypervisor. So you will see that when we are going to talk about a few products. So hypervisors are almost for free. And software in general is for free. What is happening is we are going more and more open source software. So most people, when they have this demand for lots of these, they really use open source Linux, or Unix or something, so that, I mean, the people who are using the computer, they just notice the web browser. They don't know what web browser is running on. You see what I mean? So really, open source is one thing which is happening, and second thing is the hypervisor. So hypervisor are also kind of open source. We talk about Jain and things like that. Those are all open source.
When we talk about the running speed and the software efficiency and things like that, the virtualization can only slow down the whole thing.
Oh yeah, right. Okay, so the idea is if you didn't have hypervisor, your system will run much faster. That is true, but at the same time, there is a cost, right? I mean, you got two computers out of one. You got a Mac and a Windows on the same laptop. So you save $2,000. So did you pay something? Yeah, now the things will run a little bit slow. Right? And so it's not that there is no cost. Yes, there is a performance cost to it. And those of us who have installed VM on our laptop, you know that we use VM only in the extreme cases. So for example, I have VM, but there are particular jobs that will not run on my original laptop. I need to run them, so I go to VM. Right? And I can afford the cost, I afford the performance degradation in those instances. And actually the performance of VMs is also improving. I mean, I remember previously VMs were so slow that you will never go there. Now, VMs are becoming faster and faster. And why? Because of the next thing which is coming up.
Also in data center environments, virtualization improves utilization. Because if you have a physical machine, that machine is not always 100% utilized. Right? So you can break it up into smaller pieces, you can use up the smaller pieces easily. And you can actually give that smaller pieces to more number of people to use them up. So utilization increases because of virtualization.
Makes sense.
All right. So we go to the hardware assisted. So reason virtualization is fast nowadays is because when everybody started doing virtualization, Intel had to think about it and see how we can make it better so that it doesn't feel like it's slower. Right? So there are several things in the hardware, in the processor design itself, which allow you to switch from one VM to the next VM. I mean, for the hypervisor to switch from one VM to the next VM and have them all believe that they are running on the bare metal. And those things are called Intel VT or AMD V. AMD has designed a similar thing called AMD-V, and they help virtualization. If you have those features in your computer, laptop, which you might, then you will find that your virtual machines run much faster. Alright? And hypervisors can use these instructions to improve the performance. So there are some special instructions which your processor, if they have it, then the hypervisor will run faster. And KVM, Hyper-V, VCI, all of these use these features. Okay? Finally, parallel virtual machines. So now we talked about dividing one computer into many computers, but it is also possible to combine many computers into one computer. Alright? So PVM, parallel virtual machine, is the name of a open source software that allows running program in parallel on multiple machines. So it makes 1 out of n. And the grid computing and cluster computing are very similar idea. We'll talk more detail later on, but grid computing is that basically you want to run on many machines at the same time. So cluster computing is similar idea. And finally, the word paravirtualization, which is different from parallel virtual machines, right? Paravirtualization means that the hypervisor offers special APIs for operations that are difficult to run in a virtual environment. So it offers special APIs, and that's the thing, that if you want to use those APIs, you have to change your operating system. You have to make your operating system, the guest operating system, to use those features. So you cannot take a vanilla Windows and use paravirtualization, because that hypervisor features it may not use. But if you change your Windows, which most people will not, probably they will go for Linux or something. If you change your Linux to use those features, then your virtual machine will run much faster. Okay? So requires modifying the guest OS, requires the source code for the guest OS, and so you change the code and you recompile it for the hypervisor. So for example, there are something for the code in the Linux which provides interface for many hypervisor and guest kernels. Okay? So now we have learned 4 different concepts. Let's just remember that we remember those 4 concepts. Hardware emulation simply means that you want to somehow be able to get instructions which are for a different processor on this, like so x86 on Spark or Spark on x86. That is emulation. Hardware assisted virtualization. That means that the hardware has some features which are designed for virtualization which improves the speed. Parallel virtual machines simply means that you are using n machines to look like one. And paravirtualization is simply that the hypervisor gives you some help if you can use it. All right? So that finishes the discussion on concepts. Now, there are some products that you really need to know. I mean, if you say, I know about virtualization, but you have never heard of these things, then it looks not bad. So I have just gone a little bit out of the way and put some product names here that at least you need to know the names, and when you need to know more about it, you can read the book about them or read the Wikipedia or whatnot. I don't expect you to be reading Wikipedia about each of these, but you should just know the name. So Microsoft Virtual PC, I suppose everybody has used it, right? That is for free, and every laptop comes with it. I mean, Windows laptop. And I suppose it also is available for Mac. So most people are familiar with it. Jain is the next one. Jain is a popular open source hypervisor from Cambridge University. But now it is used in the products all the time. So it is endorsed by many manufacturers, and it is actually Citrix basically provides the support for it. Just like Red Hat Unix, you have Citrix Jain. Oracle VM VirtualBox. So this is another one. Now you will notice that all of these are free. Virtual PC is free, Jain is free, Oracle is free, VirtualBox is free. So VirtualBox runs on Linux, OS or Windows and almost every operating system, and then allows you to run virtual machines. Hyper-V is not free. But Microsoft Hyper-V is part of Windows 2008 plus servers, and there it allows you a lot of virtual things. Linux KVM also is free, and as you see the name, it virtual machine. Basically, it kernel virtual machine. It uses all these instructions, and then user mode Linux is an executable kernel and a root file system to create a virtual machine. So anyways, these are some of the very well-known ones, and you should just know the name and a little bit who makes it, things like that, so that you feel that you have heard these words. But then there comes a big company called VMware, whose sole business is virtualization, and it started the whole thing in some sense. And therefore, you cannot know about virtualization and not know VMware. All right? It's like if you know computers and don't know Microsoft, and people say, what do you know? Right? So VMware is the father of virtualization, and we need to know what they sell. So their one product is called ESX, which is a bare metal hypervisor, ESX. And so basically, this is what is used in the data centers, ESX. They have another thing. Before I go to vMotion feature, actually, that I have a whole slide on that, so I will just basically say that they have been, just like Google, they have been inventing new features in virtualization every year. So one of the features they have is vMotion, which allow you to move VMs very fast while running. So you don't have to stop a machine and go to the other machine, go to the other physical machine. You can have a web server running here, and serving the web, you move it to some other place. All right? So that is the kind of thing they have, vMotion. ESXi is a smaller footprint version of ESX, but it's free. See, the hypervisors are all free. Let me say, no, not all free, but mostly free. All right? Many features require vCenter license, but the reason it is free is that if you really want to use those in any number more than 1 or 2, you need automation, and that automation is charged. All right? If you just want one ESXi, you can put it on your computer and you're all set, done. But if you want it in data center, you need 100 of them, you need a license for vCenter, which is the management tool. All right? So vCenter allows managing multiple servers, and vMotion and storage vMotion and all that. So that is not free. ThinApp is one which is used for basically portable application creator. So you can take any application, or actually some applications, most applications, and use ThinApp, and it will create a version that is portable. You can run on, it doesn't create any registry keys. It just makes its own environment in which it can run from USB keys, right? Some of you have seen portable software, right? Which runs from USB keys, and that is ThinApp. Then there is a product called View, VMware View, which allows thin client. Basically, we talk about thin clients, right? So that you can use with multiple clients on a remote server. That is a View. Fusion is for Macs. So you can run Windows, Linux, anything on the OS X. They have something called VMware Workstation, which is basically for workstation environment. The ESX was for the data center environment. Then they have something called Player, which is a freeware version of VMware Workstation with limited functionalities. I forgot the word functionality there, features. And then they have something called High Availability, which makes sure that your VMs don't, you don't lose information when the physical server crashes. So they keep backup. Then there is a file system called VMFS. So this is a special file system for ESX cluster. What is a cluster? Basically what you do is you take a number of physical servers, and you say, well, maybe a rack, and say this is my one cluster. And then the VMs, generally they will share some resources, maybe storage and things like that. So that is what it is. It is file system for the cluster. So file system for VMs. That brings us to a whole new topic. Before I go to this new topic, any question about the products? I know we just, all we did was remember the name. But it is important because if you know virtualization and you don't know ESX, it feels like you don't know anything. So you have to know what is ESX, what is vMotion, what is vCenter, and every I would say white paper, not really the paper. Every white paper on virtualization will start with VMware. Even the competition start with VMware. Because VMware is the one who invents these things, and then, so for example, this year they brought up virtual networking, and people are following that and all that. So that is important. Okay. No questions? Move on. All right. File systems for VMs. So using VMware's example, all physical disks are clustered into pools. So you have disks and you have computers, you have processors. So you put a group of processors and you put a group of disks and they all work together so that anybody can use any disk. Alright? So all physical disks are clustered into pools. Each VM has a virtual disk in some pool with extension .vmdk. How many have known the extension .bhd? Anybody knows bhd? Virtual hard disk. That is what you do with Microsoft PC. If you have any Microsoft virtual PC, your disk is BHD. In this case, it is .vmdk. It's a file with that extension. And the disk is formatted using this system, virtual machine file system, which is like NTFS. It's called VMFS, virtual machine file system. Okay. It's thin provisioning. Thin provisioning means the disk does not really take the space. So you can create a 100 gigabyte disk but have only 1 gigabyte. Because the disk size is not required right at the beginning. If you start using 100 gigabyte, you will need 100 gigabyte. But as long as you don't use it, it's very small. As you keep using it, the size increases. So the size is dynamic. Okay, so that is called thin provisioning. Thick provisioning means static, means full size is allocated at creation. So you could have thin provisioning or thick provisioning. Thick provisioning means that you could, if you say create a 100 gigabyte disk, how much will you need at the beginning? 100 gigabyte, complete. Same thing is in VHD. When you create a virtual hard disk in Microsoft PC, it asks you whether you want to do, one way or the other. I don't remember the names they use, but you have the option of expandable disk or non-expandable disk. Right? Expandable disk will basically expand as the need grows. Then linked clone, and you could have something where you really don't need your own disk. You could be sharing the disk with somebody else. How do you share? Because we are all reading from it and we are not writing to it, so we can all read the same book. As long as you don't make any marks, nobody is unhappy. Right? So that's what it is that if there's a read-only information, say for example operating system disk, why do you want to make 2 copies? Everybody can read from the same disk. Non-linked disk is separate disk for each VM and it is writable, and that would be for VM specific data. If there is something specifically you want to take a note of, you put into your own disk. And persistent or non-persistent. So you could have a disk which is deleted as soon as the VM is released, or you could have a disk which is saved when the VM is released. Why? Because you want to come back up from the previous state, not from the fresh state. Right? Everything makes sense? All these concepts? Alright? So this is what VMware does, and obviously that means everybody does in the industry now. And so the industry really needed a standard format for disks because VMware uses VMDK, Microsoft uses VHD, and XYZ uses something else. So they said, look, I cannot really move my VMs from my hypervisor to your hypervisor because you are using different format. Right? So to make it one, now there is an industry standard format called OVF, Open Virtualization Format. So basically, if you use OVF disk or a disk in OVF format, then you can give it to anybody and they can run it on any hypervisor. Hopefully, let me qualify any hypervisor. Most hypervisors today support OVF. Okay, so that makes it a really portable disk. And so it is independent of hypervisor or processor architecture. OVF is the standard set by this organization. It is called DTMF, Distributed Management Task Force. And now it is an ISO IEC standards. ISO is the International Standards Organization. Right? So it is basically worldwide standard. IEC is the International Electrotechnical Commission. So basically it is a worldwide standard now. And OVF packages consist of several files in a directory. So when you have an OVF package for anything that you want to do, it will have many files, not just one file. But there is one file in that directory which has the extension OVF. It is an XML file. Everybody knows what is XML, right? So XML file which describes what is in the directory. Okay, it could have an extension VMDK. VMDK is very similar to OVF, so that is so that will contain all the metadata required to run the package. So your hypervisor will read that file first, and then go from there. So VMware, Microsoft, Oracle, Citrix, IBM, and many others support OVF. So that's the universal standard now. That makes life easy. Any question about OVF? Yeah.
How is it made independent of hypervisor?
Because all the hypervisors support it. It's not really independent, but all the hypervisors know how to read XML. So 1.1 also allows single VM packages and multiple VM packages. So you could have a multi-VM package too. And other popular formats are VHD and VMDK. All right. Then there is a protocol called PCoIP. This is actually a VMware proprietary protocol for virtual desktops. Basically what it does is, this is for the thin clients. So when you want to do PC and you want to connect over IP, you just want to transport the desktop. So you want to do it in a smart manner so that it doesn't require too much power at the destination, at the thin client. And so what they do is, this is a content aware. So it sends the text and the graphics differently. Text is sent, very easy to send. This doesn't take too much bandwidth. Graphics can take a lot of bandwidth, but what it does is it compresses it. And so server can render it, or it can be rendered at the client. But server rendered means all pixels are rendered at the server, so no codec in the client. Client is very simple, it just flashes it on the screen. Delivery optimization based upon real-time network conditions. So as the network becomes congested, compression gets harder. It's like Skype. Skype knows when the network is congested and it reduces the quality of the voice. Layered rendering. So basically, if you keep on the same screen for a long time, it becomes better. First, it will flash it at the low resolution, and then if it gets more time and nothing changes, your screen will become better. That is called layered rendering. Can be used with or without a hardware PCoIP card, and then they made a card which you can put in your thin client, and that will become much faster. Otherwise, you can run it on as a software as well. But there are other protocols such as RDP from Microsoft, VNC, which is kind of sometimes we use, and X Window System, which is also open source. So there are many similar protocols. I am really surprised that there is no worldwide standard for this, but I may be missing something. Any question about PCoIP? Basically, this allows you to send the graphics and the text from the server to your thin client. All right, that brings us to the end of this lecture and the 5 key points. First of all, virtualization allows computation to be done anywhere, anytime, on any infrastructure. Right? That makes it very easy to schedule, and manage resources. And we need to virtualize not only servers but also storage and networks and everything else. Then we learned that the hypervisor are of two types. Type 1 run on the bare metals, and type 2 run on the operating system. This much you should basically memorize right there. Type 1 on the bare metal, type 2 on the host OS. And then the common well-known products are Virtual PC, Jain, ESX, VirtualBox, all those things, right? And then the virtual machines itself comes in a disk file name with extension OVF. OVF is the standard for Open Virtualization format.